Politics has become the science of getting one's way. One market researcher tested various euphemisms for the phrase estate tax, which wealthy persons were hoping to end. The researcher found that people did not care about estate taxes, but reacted strongly to the phrase death tax, and would then vote to end the tax. This same researcher found that people reacted less strongly to the phrase climate change than they did to the phrase global warming. Conservative politicians then switched to that less emotional phrase. In response, the rest of us will now refer to global warming as global death. For example, if global warming led to the extinction of 500 species of mammals, would that have any effect on the other species? Well, there are only 5,000 species of mammals on the planet, so 500 would be 10% of all species. Should we gamble on this to save pennies in business costs? The many factors of long-term climate are described in another video of this series. In summary, we ask what would be the temperature of the Earth if it had no ocean or atmosphere and was just as far from the Sun as it is now. Its temperature would be just like the Moon, which has no ocean or atmosphere and is just as far from the Sun. The Moon's surface temperature swings through 500 degrees Fahrenheit or 300 degrees centigrade from day to night. The Earth's ocean and atmosphere hold heat and reduce the day-to-night temperature swing to just 50 degrees Fahrenheit or 30 degrees centigrade. The equations of physics show that if the Earth had its ocean and an atmosphere of just nitrogen and oxygen but no water vapor or greenhouse gases, then the surface temperature of the Earth would be 20 degrees cooler than it is. The surface temperature depends sensitively on the greenhouse contents of the atmosphere. The atmosphere is 30 miles or 50 kilometers tall, and its temperature is minus 450 Fahrenheit or minus 270 centigrade at the top, and 80 degrees Fahrenheit or 30 degrees centigrade at the bottom, where we live. Even on a hot summer day, the temperature of the atmosphere drops to minus 40 degrees, just 6 miles, which is 10,000 yards or meters, above the ground. Coal-fired electrical generating plants, cars, and factories dump greenhouse gases and poisonous gases into the lowest 100 yards or meters of the atmosphere and raise its temperature. When the wind stops for a few days near industrial centers, entire towns are sickened and many persons die from factory exhaust. Why do factories have tall smokestacks? They are used to disperse the poisons higher into the air that might otherwise kill everyone walking past. Our very lives depend on the temperature of the lowest 10,000 yards or meters of the atmosphere, because that is where we live. We risk global death by altering this temperature with air pollution. The temperature of outer space is minus 450 Fahrenheit or minus 270 centigrade. This is the temperature above the Earth's atmosphere, which is merely 30 miles or 50 kilometers tall. That short distance above your head, the cold temperature would kill you in seconds. We human beings are able to live only in the lowest mile or two of the atmosphere, where the temperature is just right. The Earth's human population of 7 billion persons amounts to 35 persons per square kilometer. This means that each person gets a square region that is 160 yards or meters on a side. Out of the entire universe, the only place where you can live above freezing is in this little volume that is 160 by 160 yards or meters, and a few miles or kilometers in height. Don't let anyone save pennies by dumping greenhouse gases and poisons into your tiny little livable volume of the universe. Factory-made global warming began 250 years ago. As was stated above, scientists and engineers would be thrilled to design and build factories, homes, and cars that emit nothing into the environment so that we won't be gambling with global death. Factory owners prefer to save pennies by leaving out the equipment needed to keep their factories from emitting pollution and fouling our air and water. Business owners have made obscene profits polluting the world. Had they built proper processing facilities, they would have simply charged customers more. The nation's 500 billionaires and their media and political advocates care only to save pennies on buildings and operating costs and have no regard for the lives of 7 billion persons or of any other life on Earth. The billionaire Warren Buffett said, "I personally think that if society is the one that's benefiting from the reduction of greenhouse gases, that society should pick up the tab." In response, we personally think that we should fine and jail those business leaders who hope to reduce factory operating costs by emitting greenhouse gases and poisons into the air and water. Even they will benefit if we avoid global death. Antarctica has 1.5 times the area of the U.S., and it is covered by ice that is 6,000 yards or meters thick. Imagine the entire U.S. covered by mile-thick ice. You can believe that the ocean level would rise if all that ice was pushed into the sea and melted. As ice ages come and go, the ocean surface rises and falls through 100 yards or meters as water cycles between ocean and glaciers. Each coal-fired electrical generating plant burns 100 to 500 train car loads of coal per day, and there are thousands of these plants. They emit more radiation than a nuclear-powered plant. They emit the mercury that is in our waters and food supply, and their emissions cause lung disease. Half the world's greenhouse gases are emitted by electrical generating plants that burn fossil fuels. Out of the 7 billion of us on Earth, the only people who want smog, lung disease, global warming, and mercury in our food are the owners of this industry. Each coal-fired electrical generating plant burns a mountain of coal every year. In contrast, a nuclear-powered electrical generating plant gets its energy from a piece of uranium that is the size of a beach ball, and each plant creates but several truckloads of nuclear waste per year. Which is better for the environment and our health, coal or nuclear-powered plants? We must be careful to make the correct and fully informed choice. We all want to use solar, wind, tidal, and other renewables for as great a share of our energy as possible. Europe is way ahead of the U.S. in this approach. A great plan is to use windmills to charge batteries that operate electrical cars for every person. It would take a couple decades to switch to electric cars, just as it took a couple decades, back in the 1930s and 40s, to get electricity and plumbing into homes and gas stations along paved roads. Japan already has more electrical charging stations than gas stations. Our political leaders have failed us by not planning for our future energy needs and energy systems, by omitting mass transportation, even sidewalks. Back in 1975, we should have put wind-powered generators and solar collectors on every rooftop in the planet. To see how passive solar energy works, lay a water-filled hose or container for an hour in the sun or in your closed car, and you will quickly have hot water for a shower. Rather than using light bulbs all day long, sunlight should be piped inward for interior lighting. The absence of a U.S. energy policy, since that of President Carter, has accompanied 2 Gulf Wars and 500,000 of us human beings being killed by other human beings. El Nino is a 1 degree Fahrenheit or half a degree centigrade warming in a patch of ocean along the equator, and this shifts weather patterns around the globe. Global warming might raise the entire Earth's surface temperature by an average of 4 degrees Fahrenheit or 2 degrees centigrade. This also means that the temperature in big cities might increase by 10 degrees Fahrenheit or 5 degrees centigrade. Throughout the summer, the temperature in your city might be 110 degrees Fahrenheit, 43 centigrade, instead of 100 degrees Fahrenheit, 38 centigrade. We, the human beings of the world, instruct our business and political leaders that, from now on, homes, cars, and factories will be built such that they emit nothing into the environment. That way we won't be gambling with global death just to save a few pennies for a few billionaires.
The analysis of earthquake waves tells us that the interior of the Earth consists of several concentric spherical shells, and that the surface of the Earth is not formed of one solid piece of material. Instead, it is broken up into 30 sections in the manner of adjoining jigsaw pieces that geologists call tectonic plates. The continents ride along on top of the heavier crustal material in the same way that bread would float on oatmeal. Below the Earth's crust, some hotter sections of the mantle are moving upwards, while adjacent sections are cooling and moving downwards. The convective movement of mantle pushes the plates and continents around the surface of the Earth. They move at a speed of about 1 inch or 2.5 centimeters per year. This is about the speed with which your fingernail grows. This movement and speed is easily measured by satellites. Sometimes a continent is sitting on top of two adjacent plates that begin to move apart due to an upwelling of mantle material. This causes that continent to become torn or split into two pieces, which then begin to move away from each other. An ocean may develop between those pieces. For example, about 200 million years ago, the South American and African continent were not separated by an ocean, but were adjacent to each other. Still today, the shapes of their coastlines are similar. The plates move so slowly that it has taken about 200 million years for the Atlantic Ocean to have its current width of 2,500 miles, or 4,000 kilometers. Plates often collide in a process that takes several million years and builds mountains. It then takes another 50 million years for the erosive effects of the wind, ice, and rain to wear down the mountain range. There have been many such cycles of mountain formation and erosion through the Earth's history. New mountains are rugged, tall, and steep, like the Sierra Nevada, Andean, the European Alps, and Himalayan ranges, while old mountains have been worn down in size, like the Australian Alps and the Appalachians. As the continents slowly move around the planet, their climate changes, and so do the plants and animals living on each continent. For example, as a continent moves from equatorial to polar locations, its tree cover changes in time, from pine trees to palm trees. This history is determined from geological layers and radioactive dating. Through the Earth's 4.5 billion year history, each continent has spent time submerged under oceans, has had sections uplifted into mountains, and has experienced climate ranging from glacial to desert and to rainforest. When most of the continents are located near the equator, then the seasonal variation in temperature is minimal, resulting in a year-round daily temperature of about 70 degrees Fahrenheit or 21 degrees Celsius throughout the planet, and there are no glacial regions that are covered with year-round ice. We are said to be in an ice age whenever there are regions of year-round ice, such as today. Glaciation has retreated poleward from its last maximum that occurred 20,000 years ago. Notice that about 13,000 years ago, glacial retreat first allowed people to migrate overland from Asia to America. During a glacial maximum, or ice age, summer temperatures are 10 to 20 degrees Fahrenheit, or 5 to 10 degrees Celsius, colder than they are now. Through the last 2 million years, there have been about 20 cycles of glacial advance and retreat in which year-round ice has reached as far south as Kansas. These cycles are connected to the 100,000-year cycles in solar output and in the Milankovitch cycle that changes the Earth's orbit from more circular to more egg-shaped. At the same time, the tilt of the axis of the Earth varies from 21 to 24 degrees in a 41,000-year cycle, and its orbit precesses with a 23,000-year period. About 25% of the incoming solar energy evaporates water and causes the rain. Sunlight strikes perpendicularly to the ground at the equator, as shown on the left, but glances along the poles, making the equator hotter and causing wind and water currents to move. When continental positions allow ocean currents to flow from the equator toward the poles, the currents carry heat that warms the poles and keeps them free of glaciers. The ability of ocean currents to move equatorial heat poleward changes as the location and shape of the continents change through time. About 36 million years ago, the Antarctic continent moved to the southern pole, and a circumpolar oceanic current developed that conducts little equator-to-pole heat movement. The resulting glacier in Antarctica averages 6,500 feet or 2,000 meters in thickness and accounts for 90% of all glacial volume. Greenland's glacier accounts for another 9% of the total volume. The amount of sea ice occurring at the North Pole was indirectly enhanced by the joining of North and South America about 3 million years ago. This blocked an east-west flowing ocean current that was replaced by the Gulf Stream. It carries moisture-laden air northward, increases precipitation near the North Pole, and moderates European winters.
When North and South America joined, ocean currents took some time to reset, and this may be what caused the climate in Africa to fluctuate so wildly that locations alternated between desert and deep lake in a series that repeated every 1,000 years or so. It's probably not a mere coincidence that this is the time at which the brain size of our ancestors doubled.
The age of the glacial advances and retreats are determined in many ways. For one, as a glacier retreats, it exposes underlying rock to cosmic radiation. The radiation builds up through time and can be measured to deduce how much time has passed since the glacier retreated. Coral reefs always remain near the surface of the ocean, growing upwards and downwards as the level of the ocean changes. A history of their height reveals ocean levels and hence glacial volumes through time. Ocean levels and glacial volumes also give information about past temperatures, as do past longitudinal distributions of warm and cold water plankton. Geologists and paleontologists have pieced together a history of the Earth's past temperatures in many ways. Information is obtained from the types of plants and animals that are found in geologic layers because the temperature range of each species is known. Insects are especially useful in this way because each species lives in a particular limited temperature range. If a 10 million year old geological layer contains seeds from palm trees rather than pine trees, then we know something of that region's past climate. It is known that in tropical regions with high temperatures and high rainfall amounts, leaves are broad instead of narrow and have smooth instead of jagged edges. The ratio of broad to narrow and smooth to jagged edged leaves indicates past temperatures. There are a large number of factors affecting the amount of glaciation on the Earth's surface. Mile-thick glaciers cannot accumulate on the ocean surface, but can build on mountaintops. As the number of mountain ranges on the Earth varies through time, the total volume of water held in mountain glaciers also varies through time. Continental glaciers can occur whenever a continent is located at a pole, during a time of both cool temperatures and high precipitation at polar latitudes. Glacial buildup most rapidly occurs in the process of warm equatorial oceans with poleward currents. The continental positions, shapes, and groupings also determine if sea currents can carry warm water from the equator towards the pole. The amount of sunlight that reaches the ground to be absorbed by the Earth's surface depends on how much is reflected back into space. The reflected portion of solar energy depends on the distribution of land and sea by latitude. The percentage of ice-covered and cloud-covered land the nature of the land surface. Seas absorb sunlight, while ice and desert reflect it, and the composition of volcanic dust held in the atmosphere. Through the last few centuries of industrialization, we humans have been altering the chemical composition of the atmosphere sufficiently to change its absorptive and reflective properties. Many man-made chemicals, from carbon dioxide to soot, are contributing to global warming.